Hello and welcome to my YouTube channel. How's the Joes? I know your Joes is high. Today I will begin with your interesting topic, very important topic, and that topic is Chapter 8 Gravitation. In this chapter, two important things I will explain today, and they are orbital velocity and escape velocity. So, what is orbital velocity and what is escape velocity? First of all, orbital velocity. Orbital velocity. This orbital, this word itself explain about its meaning. Orbital means a satellite in a certain orbit, and velocity, the velocity of satellite that is occupied in that orbit. Suppose Earth is here, and from surface of Earth a satellite is revolving in this certain orbit with velocity v0. So, orbital velocity is the velocity of a satellite in a certain orbit with which it revolves around that orbit with respect to the Earth. Okay? So, I think it is a very simple word and simple definition. Once again, I am speaking out about the orbital velocity, a certain velocity given to a satellite in a certain orbit with which it revolves in a circular path. That is the orbital velocity. What would be the value of the orbital velocity? Now let us find the value. Let v0 be the orbital velocity, and let v0 orbital velocity, that is the orbital velocity of the satellite, that is orbital velocity, m, small m, mass of the body, that is satellite, mass of the body, mass of the satellite, you can say satellite. Capital M, mass of Earth, capital R, radius of Earth, this one, H, height of the satellite, height of the satellite from the surface of Earth, from the surface of Earth. This is the consideration. Now look at the simple diagram that will give you some concept to find the orbital velocity. That means this is the Earth, its height is small h, small m, this is the radius r. Let small r is r plus h. Here let small r is equal to r plus h. The velocity, that is orbital velocity of the satellite, is v0. The centripetal force, that is due to centripetal force, there is also a force that is appeared to be, that is centrifugal force. That force is balanced by the force of gravitation between the earth and the satellite, that is gm small m by this whole distance, that is r square, is equal to mv naught square by r. This is the force that balances the gravitational pull. So small m cancelled out, this one cancelled out. Now v naught square is equal to gm by r. Therefore v naught is equal to under root gm by r. This is the orbital velocity, where small r is equal to r plus h. So this is very simple. Its definition is simple. Its derivation is simple. You have to note in your mind. Okay. Now let us explain about escape velocity. Escape velocity is very different. The escape velocity is defined as the following manner. It is the velocity required to escape the satellite from its certain orbit to infinity, or you can say the velocity required to that could make free this satellite from the gravitational pull. The certain minimum velocity, and that is the vertical velocity, that is ve, given to the satellite so that it could be free from that orbit and could go to infinity, where there is no any gravitational influence. Okay. So certain velocity given to the satellite that could make the body free from that orbit and that could go to infinity. Okay. This is and never come back also. Infinity, that will not come back. So ve is, let ve, here is escape velocity. Escape velocity. Let v naught escape velocity. Escape velocity. And again, this is the r distance, this r plus h, this is r, and this is the radius. I have assumed r is equal to r plus h. Now one thing which is very much important, that the total energy at this point of time when the satellite is about to go to infinity, that is when we are giving a velocity ve, that is k velocity, then at that moment what is the total energy? One is potential energy, that is minus gm small m by r, and plus the kinetic energy due to ve. This is the total energy at this point of time. And if you want to make it go to infinity, then it should be this total energy, this should be equal to 0. Very simple thing. Now you can simplify it. This is half mve square is equal to gm small m by r. Small m cancel. Now ve square is equal to 2gm by r, and this implies ve is equal to under root 2gm by r. This is the expression for the escape velocity. Very interesting, very important, and very cute formula. Okay. Now one thing we are witnessing here, that what is the relation between escape velocity and orbital velocity at the same distance, for the same distance, that is small r. What would be the relation between both? Look at, relation between escape velocity and orbital velocity. This is very important because in numerical or in conceptual type of questions it might come. So the relation between escape velocity and orbital velocity, very simple, in very simple way. We know that the escape velocity v is equal to under root 2 g m by r, equation number 1, and again v naught is equal to under root gm by r, equation number 2. Divide 1 by 2. If you divide it, then you will find v naught under root gm will cancel, this r and r will be cancelled, it will be under root 2 only, and this implies ve is equal to under root 2 v naught. That means escape velocity is under root 2 times orbital velocity. It is very much important. Okay, for the next video for geostationary satellite and that's height, wait for that. I think you have understood and got each and every concept of this lecture, but what is remaining now from your side to subscribe it. Thank you.